Hi and welcome back. In this lesson we're going to talk about arrays and look at two programming templates for working with arrays. First thing I'm going to demonstrate is how to declare arrays in your Go programs. And there's a few variations you can follow. The first one, probably the most traditional, would be to make a declaration by stating the name of the array, the size of the array, followed by the data type. Of course, starting off with var. So var number sub 10 int, saying that I want a integer array that consists of 10 elements. Another possibility, this is actually the same example. Just demonstrating another data type here. So let's look at a second possibility. Here we're going to let the compiler determine the size by looking at the initialization list that I am typing in right now. Just like that. So the ellipsis indicates that we're going to let the compiler determine the size based on counting the number of elements in the list. So this is going to be a string array of 4 elements with the 4 names. Finally, we can also use a short declaration with an initialization list. And this might be the most efficient of them all. Whoops, if you're adding data into the array at declaration. Excuse me, at declaration. So, those are the different ways that you can declare an array. Now let's take a look at how we would fill an array with data. That's our first template, our fill an array. So let me put a little. So the way we're going to do that is we're going to declare a constant to represent the size of the array. We'll use that constant to declare the actual size and declare the array. Then I need a variable to store each number that I'm going to put into the array. Then our for loop. And we're going to prompt the user to enter a number. Oops. Oh, got in caps lock somehow. Get the number in, and then use, see, we have to change our loop. So let's change that to 0. Helps to think about what you're doing. Okay, so we've got to start with 0, of course, because your arrays are always indexed starting at position 0. So we're going to start at 0, go up to but not including size, since we have 5 elements, that's 0 through 4, and then increment each time. Close the loop. And then we could also print the array, which is a nice little feature that lots of languages don't have, that I can use it as in an aggregate to print the elements of the array. So let's save that program, and then let's run it. Take it just a moment here to compile. Alright, so let's put a few numbers in. And there's our array. So that's one way to fill an array using interactive input, a very common way to do it. Another way to do it would be to use random number generation. So let me demonstrate that. We're going to need a couple of packages, so I'm going to add those to my import statement right here. Oops, there we go. And we'll leave these first two the same. I'll just start over again from here to there. So the first thing we're going to do is we're going to create a random number seed, a random number generation seed. Then we're going to create a random number generation object using that seed so that we get a new number every time. Then we're ready to I'll just save it like that. So int n is a function that will return a random number from 0 up to the argument, but not including the argument. And so that should give us all of the numbers that we need, 5. So let's take a look and see if that works. And there's our numbers. I love using random number generation when working with arrays because it's a whole lot faster than trying to enter the data myself, especially when I have a large data set, hundreds or even thousands of numbers to test some other algorithm. So what I want to do now is look at one other template. So that's the fill an array template, which we've done. Now what I want to do is work with another template, the process every element template. Oops. So what we're going to do now is we're going to, let's go ahead and put that print back in. We'll just leave it like that, that's fine. All right, so now what we want to do is we want to find out the average of the numbers in our array. So we're going to include a variable for the total. Then our loop, which does what it always does, starts at 0 and goes up to size, but not including size. Add all those into the total. Then let's compute an average. And to do that, we're going to cast both total and size as float 64s. So that we'll get a floating point result. And then let's see what our average is. Let's put a backslash in right there. And that all looks correct. So let's save, and compile and run. So of 19, 44, 28, 23, and 13, the average value is 25.4. So the only other thing we might do here, and then we'll end this video, is we might replace our indexed for loop with a range for loop for lots of reasons, but primarily because with the range for loop we don't have to worry about going outside the range. So the range for loop returns two values. First it returns the index of each element, and then it returns the actual element of the array itself. So that's why my for has two indexed variables. The underscore for the index, which I'm just going to throw away, that's this value right here, and the number, which is going to store each number from the array. In this we're going to say total plus equal number. And that's really all we have to change. So the range for loop, when you're processing every element of an array, you should always use the range for loop in your code. So let's save that. Let's clear the screen and compile and run. And this time we get an average of 51.2. That 23 and that 15 really knocked down our 65, our 68, and our 75. So that's our last little loop. And so we've demonstrated a couple of array processing templates here. Fill an array, we demonstrated one way to do it through interactive input, and then the way you're looking at on the screen now through random number generation. And then the process every element template used another indexed for loop the first time, and then we demonstrated the preferred way to do that, and that's to use the range for loop so that we don't have to worry about going out of bounds either before the array starts or after the array ends. So thanks a lot for watching, and I will see you in the next lesson.